My name's Simon Lydon. I'm the Director of the Centre for Personalised Medicine here in Oxford, and it's my huge pleasure to give you a very brief welcome to this second in our Ethics and Personalised Medicine series. This one is all based around one of the particularly thorny issues in personalised medicine, which is intellectual property. It's a fantastic conference, 1.5 day conference put together by the organising team, and I'd like to thank them very much, which is Katerina, Mark, Angeliki, together with Thea and Kath from the CPN and Sarah Wordsworth from the Health Education Research Council. So thank you very much to everybody for coming. This is a sort of combination of groups here. This is the Centre for Personalised Medicine, ETHOX, and the Health Education Research and the Research Council getting together to put these three conferences together. We have a third conference which will this time next year, and that's all based on resource allocation. So please mark your diaries. You'll find an advert on the back of the programme. And I'll say no more except to hand over to Katerina, who is chairing this first session. Thank you very much.
Thank you. So we will begin the day with our two keynote speakers, and today we have a lineup of very interesting speakers from the public and private sector as well as the academia. But we will begin with the two keynote speakers for this year's conference, Professor Shobita Parthasarathi from the US University of Michigan and Professor Graham Dutfield from the University of Leeds. So Graham Dutfield's work on IP in the life science industry has deeply influenced how we think about the troubling relationship between the pharmaceutical industry interests and the patent system, and how to build a patent system that meets certain objectives, such as promote the health of the population while establishing or maintaining an innovative, wealth-generating pharmaceutical industry. Shobita Parthasarathi's work on the comparative politics of healthcare and patenting life forms gave us a totally new perspective of the politics of public policy, bringing to the foreground the role of civil society and the much neglected link between IP and democracy. So Shobita's work discusses issues concerning innovation and the public interest and invite us to rethink what counts as good IP governance. So without further delay, I will give the floor to our speakers. So it's 40 minutes presentation for each speaker, followed by 10 minutes Q&A. Thank you very much. Graham.
Okay, thank you.
Yes.
That's, by the way, my very bad photograph of I took in the Oxford Museum. The fact it's a bad photograph makes it better than if it were a good photograph, oddly enough, in my opinion. Right. I pose a question here about patentability in the area of personal medicine, and the question is, have we gone too far? And I guess my answer is probably we have, but it's not 100% conclusive, because I think the jury is somewhat out. We still need some more evidence, and I would like people to bring up their evidence, and if I can get some funding, I'll do it myself, but it might be easier if someone else does it, because whoever's best at bringing the money. All right, now before going further, personal medicine, I tend to treat precision medicine, scientific medicine, stratified and personalised as not identical, but slightly overlapping. And now, that's my basic assumption, that these concepts do somewhat sort of overlap, but are not exactly the same. The patent system is a very sort of dynamic system, but in a sense, it's always, or it has for a long time, been based on the idea of being sort of just good enough. A bit like a PhD, right? A PhD has to be just good enough to get your doctorate, right? It doesn't have to be a work of art, doesn't have to be a work of genius. Most people are not geniuses. I'm certainly not one, and I managed to get a PhD. And this has a basis in law that goes back a long time, right? And when I teach patent law for the first time, I bring in coffee lids, right? I have this slide to unlock sort of coffee lid, right? To make the point that this is relatively trivial, but it is still a patentable invention. There are lots of patents on coffee lids. And it doesn't even have to work that well, right? If you're running through a train with a coffee lid, the likelihood it will still burst off and you'll get hot coffee all over your clothes, right? It's not that great. You know, and a lot of inventions aren't that amazing. They don't have to be. You don't have to be a genius. You can be just dead lucky. So, and it can cost you a lot of money, or it can cost you almost none, right? It doesn't really matter. The patent system doesn't sort of discriminate. As long as it meets the criteria, it is good enough, and that is all we ask. A good question to ask is that acceptable? I mean, should we expect to be more than just good enough for your 20-year legal monopoly? Well, I'm not going to answer that question now, but it's as well to reflect on it. If you cross the Atlantic, another old case, a very similar point is made. Again, 19th century. It can be very humble contrivance. It can be of limited usefulness, the fruit of indifferent skill and trifling ingenuity, as one of those grander products of genius. Now, okay, so two hypotheses I want to put forward. One, novelty has been relaxed for certain medical inventions, and this is a privilege generally unavailable to invention in other fields. It might be wrong, but I'll throw it out there as my first hypothesis. Second, is that no adequate case has been made to prove the public benefits overall, while additional burdens are placed, at least potentially, actually, on health service providers, physicians and pharmacists in order to sort of, in a sense, sort of police the sort of system against infringement. You've ever heard about sort of things, that sort of skinny labelling and what doctors are not allowed to put on a prescription. So patent expirers and sort of generic competition are generally seen as providing the context for pressures to extend patentability to new types of subject matter covering existing products. Of course, patents are all about, in a sense, limiting competition for as long as you possibly can. And for many, that is a perfectly reasonable business strategy to adopt. But in a sense, the personalisation turn, as you might call it, is a further sort of driver of the situation. So issues arise from the lack of personalisation and precision. And so what, personalised medicine, what is it, what problems is it meant to solve? Or what is happening that's bad in the absence of personalisation? One is that many, many drugs don't work for the people who actually are given them. Sounds quite damning, quite depressing. Not one of the 10 best-selling drugs in the United States helps the majority of patients who are given them. That's in an article in Nature, so I guess it has some sort of authority here. Sounds rather sort of depressing, doesn't it? Second, of course, drugs do kill people, and actually quite a lot of people. Obviously, often people who are already pretty sick, right? And why is this happening? So why do the drugs not work? Well, among other reasons, there are obviously variation from one person to another. Human genomic variants, microbiome, obviously lifestyles, environment, any combination of these factors. So is drug failure, is it a matter of quality or is it of a lack of information about the individual and the disease? Of course, information is incredibly important in all this. What types of information? So personal medicine really is about the right drug for the right person if you narrow it down to a sort of a slogan, a statement. And of course, what is happening is that out of one disease, particularly complex diseases like cancers, out of one disease, we have many. There is the splitting of diseases into categories and subcategories. 100 years ago, they talked about disease of the blood, and then we talked about leukemia or lymphoma. 60 years ago, the number of different kinds of disease of the blood has massively expanded. Obviously, it's all to the good that this sort of knowledge is being gained. All right, so as you have out of one disease many, there's also this kind of lumping and splitting of patients. And biomarkers do play an incredibly important role. Now, from the perspective of business, there is a apparent dilemma here, an apparent dilemma. Industry has always gone for the blockbuster model a long time. So industry tends to prefer drugs that all patients can use, and of course that can be used over a long period of time. So broad spectrum, you might say, drugs that many people will use. And of course, personalised medicine is a challenge there because it targets highly specific disease classes or patient types. And so in a way, you could say the market seems to be making itself, science is making the market very small instead of very big. So do you go for the partially effective products for many patients, or do you go for the sort of magic bullets for small populations? It would seem, superficially, it would seem, well, surely you'd want to go for products that a lot of people would take rather than a small number of targeted people. But the reality has become rather different. A very good example of this is Gleevec, which is for a particular type of leukemia. There are three people involved in the discovery of Gleevec. And I had rather fun writing an article about who really sort of discovered Gleevec. Was it the person whose name on the patent? Or was it the other people who did all the sort of conceptual work? And actually, really, the conceptual work was not done by the named inventor of the patent, Jörg Zimmermann. Just, obviously his role was extremely important, but really Drucker and Lydon seem to be to play a much more important sort of conceptual role. Although the work, Gleevec was based on important work, science done over a period of, 30 to 40 to 50 years, actually nearly 60. I say with slight sadness because that's the year I was born, and I'm getting close. Right. So over time, they managed to link a sort of chromosomal defect with a particular specific form of cancer. And I did once meet Nicholas Lydon, and I did say, is industry, is it attuned to the idea of the highly specific drug targeted at an individual, at a small number of patients as being, because he was one of the people who had to persuade the company Novartis that there is a market for this, and you have an obligation to make this available, because Novartis thought, well, there's no money in this because not enough patients to make it worth our while. And Drucker managed to persuade them that actually there's a market in this. And of course, they made tons of money. Interestingly enough, Drucker is not in the private sector, but he was the one who is instrumental in persuading the company that there is a market for this product. And of course, it's quite expensive too. It has been. Another good example of how this sort of precision or personal medicine works is a drug called Iressa, which is for non-small cell lung cancer. I remember we all used to say lung cancer. I didn't know about non-small cell lung cancer. I mean, how many lung cancers there are? I imagine a growing number. Now, this is a drug that didn't work very well for most people. It was a very mediocre product in terms of response rate for patients who actually received this drug. But an article in Nature 2008 noted that certain subsets of patients, such as female non-smokers and Asians, had some remarkable responses to the drug, but they had not yet found a reliable biomarker. A year later, they actually did, and of course, it gives this product a completely new sort of lease of life. All right, so this sort of precision targeting for a small population can turn out to be. I shan't go into symptom because that's don't have time for that. Of course, this is open to abuse, and I just saw actually today on the IPCAT blog. So this is sort of hot hot off the press, you might say, at a conference in Basel, where a chap called Dominic Schnuckels from DG Health noted that, because this is a potentially bad as a consequence of the splitting of drugs, is that if you get a small enough number, if you split so much that the number of patients who suffer from that particular version of the disease is very, very small, then you get all the privileges, the market privileges of being an orphan drug, right? And that, on one hand, can be an extremely good thing. On the other hand, it can be quite a bad thing, because it does make possible a certain amount of playing the game. So a certain amount of sort of perverse behaviour in industry. Okay, so what gets patented? And I'm just going to focus on Europe, because if I talk about Europe and America together, we'll be talking for a long, long time, and the conversation will get immensely confusing. This is confusing enough, but this is a sort of list. I guess other people may come up with a slightly different list, but what gets patented in this area? Well, obviously new products and processes, that's nothing new at all. Further uses and new methods relating to new indications, optimized or personalized dosage regimes, and patient subpopulations. Now, I'll explain how that works, and then so on, all right? Genes and biomarkers, etc. So there's an immense amount of, sort of splitting, in a sense, in terms of what is patentable as well. Now, so patent issues related to personalised medicine. There are certain types of subject matter that get claimed, whose acceptance will, of course, expand the scope of what is patentable. So, you know, genes, incremental sort of product inventions. You know, you may have heard about the Gleevec case in India, a particular as a crystalline form of Gleevec. Nobody sought to patent, and it failed, at least in India. Methods and use claims for optimizing or personalizing dosage regimes. And I mentioned a few cases. Of course, you know, Prometheus is United States, not a European case. And which I find fascinating, use of old drugs for newly defined groups selected from a larger patient population, right? And of course, there are certain types of certain provisions or measures which actually potentially sort of reduce the scope. So there are countercurrents, right? So we expand the scope here, but we somehow put these things in which you might say sort of counter that trend in a way. So I think we all know about surgical therapeutic diagnostic methods of treatment. Also, of course, non-statutory exclusions. You have those four in the United States, for example. We also have the pharmacy or the clinical exception in a lot of countries, including, I think, the European patent, the Unity's patent, which we may or may not be a part of. Who knows? Who knows what's going to happen to any of us a year from now? Bewildering, but we have it in UK law, of course, as well, or, you know, already. So I guess that will stay in Europe. So there are sort of countercurrents. So let me say a few words about methods and use claims for optimizing or personalizing dosage regime in relation to some cases. This is a British case, Activist versus Merc. Now, this was interesting, quite a groundbreaking case. There was a secondary patent which claimed use of an existing drug. This is a Swiss type claim for the treatment of a different illness. Now, I think that was found anyway not to be novel anyway. So the novelty of the whole invention hinged on whether the different dosage regime, which was the only really thing that seemed to be potentially novel, was that enough? Was that enough? A different dosage regime from 5 milligrams a day to 0.5 to 0.05 to 1 milligram a day was that dosage regime, sufficient to make this a patentable invention. And the Court of Appeal said it was. Because there was deemed to be a low expectation of success, you couldn't have sort of predicted. It wasn't an obvious thing to predict. So that dosage regime in itself was seen to be patentable, and this is consistent with a European case where patentability is not excluded where a dosage regime is the only feature claimed, which is not comprised in a state of the art. So that is a different treatment, even though it's by therapy of the same disease, right? Is that novel? I mean, do we want to reward that with a 20-year legal monopoly? Is a question I just throw out there, right, to think about. And then this one, which I find really fascinating: use of old drugs for newly defined groups selected from a larger patient population. Now, I actually read this case. And I came to my own interpretation, and then I read a textbook which had a completely different interpretation. I thought, well, maybe I'm wrong here. And I read an article by Sven Bostein, who's in this room, and he sort of confirmed my interpretation of this, I think. This is a case. Here we have a drug that already exists, right? For a health problem that is already used for, and for patients who get this drug. Now, the question arises of, if you identify a subpopulation of those people, including people who maybe already been getting the drug, if you can find a way to scientifically identify a subset of the population who would, let's say, who are more likely to actually benefit from the drug in a way that marks off as a selected group out of that larger population. Would that be, can you find in here a patentable invention, right? And the answer is that yes, you can. Right. So you can get a patent where involving the identification of a subpopulation of patients who are already getting the drug for that particular disease. Obviously, this highlights also the importance of finding biomarkers, some of which can be, in a sense, extremely valuable. All right. Now, what are the dangers? Are there dangers of, you might say, incentivizing or perhaps over-incentivizing these kinds of invention? Well, what are the arguments for, you might say, well, there's still, okay, the R&D costs are much, much lower, but they're not necessarily negligible. It is a 20-year sort of legal monopoly. You have the same set of legal rights as if you come up with a new life-saving drug which saves millions of people. It's the same. And going back to the first slide I showed you, that is sort of consistent with the principle that an invention has just to be good enough. But on the other hand, you can find examples where, as the article, title of this article, too many roads not taken. Are roads not being taken because you are generally exploring variations of what's already out there rather than engaging in radical innovation, right? And I guess there is an economic argument here that if it is too easy to get a patent where you are you are doing something with an existing drug, which of course may still be very socially useful, we're not necessarily encouraging actually some radical innovation, which is more risky, because the legal monopoly you get is going to be just the same. And this is an interesting example referring to about kinases, and of course Gleevec is a kinase inhibitor, so it is, it's likely there's lots of other interesting work that can be done there, but perhaps we're not providing sufficient incentive, at least for the patent system. Not that the patent system has ever been the only means to incentivize research and development. Okay, so to revisit my hypotheses just for discussion, I'm suggesting that novelty has been or is being relaxed for certain medical inventions, and this is a kind of privilege. A privilege which might be good, right? Sometimes we give privileges and we do it for a good reason because we all benefit. In a sense, IP itself is a set of privileges. But has the case really been made that we should be so expansionist in this particular area? And I'm suggesting that the burden of proof should lie on those who support this kind of expansionism more than those who counter it. But those who counter it or who question it should still, obviously, there's still, we should still do our best to find the evidence to support what we argue too. And I want to finish off just for a couple more minutes, just to say a few words about the sort of digital turn in health as well. And I've started to do a fair bit of reading in this area, and of course, personalised medicine is very sort of digital. It's not just about chemistry here, not just chemistry. The amount of data that is deemed to be health relevant has expanded enormously. You may have heard somewhere about algorithms where used to mine the text of what people write or put up on social media, on Facebook, LinkedIn, etc., and finding sort of key words which may be indication of a person suffering from depression, right? So there's massive expansion is what is deemed to be sort of health relevant, and we've all heard a lot of talk about big data, and this does give rise to a number of questions, not beyond IP, but there are a few intellectual property related questions as well. That in a way patients are an enormous source of information that needs to be harvested. I love the word harvested here, as if we are, as if we are fields of crops or something to be harvested, right? And of course, the massive health implications of this, but it does raise some really tricky sort of questions as more and more data is included from more and more different sources, some which are private, some of which are public. So I'll just finish off the last slide just so that we're not just talking about patents and drugs, personal medicine. We're also thinking about other areas where ownership, access, and property do come to the fore as important areas of debate. And I think much of this is not at all settled, all right? And I think this is areas we need to really have some good sort of conversations about ownership. Who owns data? What happens when whole genome sequencing of every individual becomes commonplace, as included routinely in medical records? On what legal basis is ownership and control sort of decided? And you notice, these companies like Apple, Microsoft, Google, increasingly moving into health, and this is really, I think, quite significant phenomenon. Healthcare companies are not, the days of big pharma as being the one actually dominant in health, perhaps really is changing. I mean, I'm writing a history of the pharmaceutical industry, and I start to think, is this now a time when those big, large corporations are being challenged by newer players? I mean, there's been amazing sort of continuity. I mean, Bayer has been here for 160 years, right? And other companies like that. I mean, most of the big pharma companies now are actually descendants of companies that have been here for a long, long time, and this is starting to change. But I slightly sort of digress here. But a number of other questions coming out. Can patent monopolies lead to data monopolies? Well, that's argument that's been used to criticize Myriad. Myriad has had these monopolies on these gene testing, and actually they've been able to get data obviously back from each individual person tested to sort of fine-tune their work, but also perhaps to explore other commercial possibilities, which are not just beneficial for individual patients, but maybe actually beneficial more widely for the business model. Should they, given that in the United States at least, they're given a monopoly, the extent to which they should not have been given, because the Supreme Court can't have retroactive effect. But the fact is, if the Supreme Court's got the law right, and it is the Supreme Court right, it means that for years, those isolated DNA patents they had were used to support a monopoly, which enabled them to get data that was private and which they do not have to share even now. And etc. And we also get into the area of database rights in Europe and also copyright. So, and I actually think increasingly sort of copyright has to be part of the conversation about IP in health, perhaps more than it has been for the last 150 years. The industry has been a trademark, a patent and trademark industry. And maybe those days are starting to change. We thought that was complicated, but I think it's going to get a whole lot more complicated. Thank you very much.